Yeah, Vrinda, it is live. Please proceed.
A very good evening, everyone. I am Vrinda Gandhi. Welcomes you all in Microsoft Azure workshop on building with Cosmos DB. Before that, I'd like to shed some light upon the plethora of opportunities that await students at UPES CSA. We are ecstatic to present before you all the opportunity to be a part of UPES Cloud Security Alliance CSA, the first student chapter of the International Research Organization Cloud Security Alliance in Uttarakhand. We provide you with a variety of communities to choose from and an abundance of opportunities that avail that is directly provisioned by our collaborators like AWS Educate Student India, Nvidia, Code Warriors, Education, and AWS UG Dehradun, to name a few. Now it is a moment to share the light that we have Mr. Subhasish Ghosh, a cloud solution architect at Microsoft, who has more than 15 years of work experience across some countries and has received multiple certifications on Microsoft Azure, AWS, Oracle, and many more. He's been a speaker at many institutions like IIM Udaipur, VIT Vellore, BMS Engineering College, and an Azure Developer Community Conference also. Now I request Mr. Shubhasish Ghosh to take over the session.
Hey, hi. Thanks, Rinda. Thanks, team, for the introduction. Pleasure being here. So, I am Subhashish, and as mentioned by Rinda, so I'm basically a cloud solution architect focusing on data and analytics for one of our large global accounts within Microsoft. So, thank you for your time. And what I'll quickly do is share my screen, which I hope will work. Yeah. So, can you see my screen right now? Yes, I think so, right?
Yes, sir.
Yeah, thank you so much. So basically, we will take a look at one of our premier, what we call, NoSQL offerings in Microsoft, which is referred to as Azure Cosmos DB. It's been used explicitly by a lot of customers who are kind of trying to solve very complex problems around 4 V's of data, if you're aware of, right? I'm sure the big volume, velocity, variety, veracity, and all of that, right? So we'll take a look at that. As a role, as I mentioned, I focus on data analytics, and within data analytics, you have basically solution patterns I work with. So I work with customers on things like how to optimize workloads, how to design patterns based on read heavy, write heavy workloads. Then how do you do query optimization? Then choice between SQL, NoSQL, which is a large, let's say, area of discussion. And then of course hands-on on Cosmos DB using different APIs. If you have any questions, always feel free to reach out. So we'll take a look at what is Azure Cosmos DB, the basic concepts, because we have just an hour time today, and it's quite a large, complex topic. So we'll definitely cover the basics so that you are aware of Cosmos DB, and you can start using it. In fact, post this session, and we will also do some hands-on coding because it's a developers database. Classically, of course, DBAs and solution architects can use it, but it has some very specific SDK features, software development kit features for different language support, which when used by developers correctly, they can build highly scalable, and horizontally partitioned applications. That's the core of Azure Cosmos DB. Now, quickly also, we will do a demo. We'll do some hands-on on .NET and Java. So assuming that you have a little bit of skills in .NET and on Java, you'll find all of this very useful. Uh, Now, what's the use case here? Like basically to start off with, like, so scenario, you have to think as if, let's say, you are a lead developer, or maybe a solutions architect, or maybe a lead applications architect, right? Could be possible. Let's say in an e-commerce company, and the team comes to you and tells, what, we are trying to build a line of business application. Now, the line of business application has to be such that it basically suffices needs of high scalability. It can scale it. It needs to have high availability. It needs to have certain specific service level agreements on performance, on latency, on storage, on throughput. So we call these SLAs of different design decisions, right? What kind of database will you choose? And of course, as you know, right, every business transforms now very frequently, right, because of the post-COVID scenario that we all exist in, right? So how do you kind of cater to choice of a database where also you kind of the build an application which is responsive to if I choose the words correctly, continuously changing business needs. And you can cater to, let's say, I make it a little more complex, that build me such an application which also caters to structured, unstructured, and semi-structured data. All of this. So basically, then it comes up to like, how do you kind of build such a database, and what's the design choice there? That's the core of it. So think of this as the scenario to start with. Now coming to coming to now the design choice, right, for our Microsoft's offering around the NoSQL databases. The premier offering around this is Azure Cosmos DB. So in a sense, right, Azure Cosmos DB's core proposition is what we call that it's a fully managed, globally managed database, distributed database service, and it's specifically also engineered, to what you call by Microsoft for building certain modern applications. Now, modern applications, again, as I mentioned, have the need to be highly available. When I say available, means not just the uptime of the application itself, but it should be available in such a way that it should also kind of suffice to serving the operations. When you try and connect, you do upserts, inserts, deletes, querying, right? It could be a simple query or a filtered, very complex query around predicates, right? So basically, all of that availability should be there for you. Very important. Again, post that is how do you kind of help me build specifically low latency applications? It's a world in its own, right? Like last mile. So you're talking about not seconds here, you're talking about milliseconds here. So read write, let's say single digit response plays a very, very, very vital role. So how do you achieve auto scale? Kind of to process very high number of operations per second. So all of these things right now that I mentioned, packaged together as a single service on Microsoft Azure, is what is referred to as, or what is called, basically the Azure Cosmos DB. So it's basically a service. Do I need to install any software in a virtual machine? No. Do I need to buy any hardware for this? No. Do I need to maybe buy some, lease some hardware, lease some data center for all of this? No. If you are on a public cloud, that is Microsoft Azure, which is an offering of Microsoft, then this comes as a pre-packaged service for you to leverage. That is what we're gonna talk about and focus in this particular session. But I wanted to touch upon that, right? Because there are multiple other services which are kind of very similar, I wouldn't call it, which are there in NoSQL industry, where you choose the database and then build on top of it, but the management lies with you. Here in Cosmos, absolutely, you don't have to worry. All of this headache is taken care, by Microsoft for you. Now, to understand Azure Cosmos DB, now we have to understand basically, what a NoSQL database is. Now, simply put, NoSQL databases, they are a bit different from traditional databases. Like when we call or use the term RDBMS, right? Examples like Oracle, Microsoft SQL Server, IBM DB2. The core fundamental is that in NoSQL databases, right? You specifically design applications and use a specific NoSQL database to satisfy certain requirements. So NoSQL databases are mainly engineered for what we call, handling large volumes of data coming in per second. And that's where the use case, for example, a real-time use case or a streaming data coming in your application, let's say you need to ingest it in high volume, high velocity, and then kind of store it for different analytics. So these kind of use cases are perfect, for what we call, NoSQL databases. Another thing also, which it is extremely well kind of suited for, is handling not only the 4 V's of data, but also the data format. So it could be structured, unstructured, or semi-structured. In other words, any data forms in any data type can be handled by NoSQL databases. So one of the other big differentiators is what we call specifically dynamic data schemas. So what that means is you can store different types of data, but you don't need to define it what we call programmatically beforehand. In fact, we will see that in our kind of demo as well. So you can change the schema as you feel fit, and as the schema changes, right, the data can come in and evolve on its own. So it's very well suited for those kind of use cases. And then again, very, very important, NoSQL databases are usually developer centric. So practically all NoSQL databases out there, if you do a comparative analysis, right, and specifically Azure Cosmos DB, as such, supports a lot of programming languages. So Java, of course, being the primary of it, .NET, these two being the primary two SDKs. Node.js via different SDKs, PHP, and so on. We also expose what we call, technically server-side programmability object in terms of JavaScript. That means basically you can create things like stored procedures, triggers, custom UDFs, and so on, user-defined functions, right? To write kind of expose business logic into code itself. So all of that is supported using, JavaScript. So if you have a use case where there are massive, volume of data, velocity of data, data format you don't know in hand, and you don't, and there is a dynamic schema in question also, and you need expose to kind of different APIs by your application. That's when NoSQL kind of rules supreme, and Cosmos DB of course shines through here. The key takeaways now, if you see, so this is basically a diagrammatic, let's call it, representation of Azure Cosmos DB and the different APIs that it supports and the different capabilities as well. So there are certain key takeaways from this slide. We will cover a few of this today, but just to remember. So one is definitely we provide guaranteed speed at any scale, which is very, very important. So if you want instant limitless what we call elasticity, so if you're talking about very fast reads, very fast writes, so how do you define technically a fast read or a fast write? I'm talking about a single digit millisecond latency. That means, let's say last mile you're doing a read, we give you a guaranteed time of 1 to 3 millisecond, and write it's around 6 to 7 millisecond. But in very simple English, it's less than 10 milliseconds. That's a guarantee as an SLA which is provided, right? And then you have very fast, flexible application development. So as you can see, there are different APIs available to you. It's an application programming interface, right? The core is the Core SQL API, we call it. And then you also have a table API for different kind of workloads with you're just doing a key value pair store, right? So you should choose a table API. Folks who are doing on-premises lift and shift to cloud and specifically working on a write-heavy database like Cassandra. So you have the Cassandra API, which we expose. Then there is a whole world of NoSQL around MongoDB. So we do support the let's call it MongoDB API through wire protocol support. All you need to do is basically migrate data from MongoDB to kind of Cosmos DB, change the connection string, and your application starts running within a second. And Gremlin is a world of its own. So this basically is a different discussion altogether. So there is a world of what we call graph databases. So these are specifically databases where you don't kind of let's call store data in a relational format, because instead of doing the standard CRUD operations, right, it is important that you kind of traverse what we call the edges of the relationships of the vertexes. That's where basically Gremlin kind of rules supreme. So Gremlin is basically the Apache Tinkerpop standard, if you're aware of this term. So our implementation of the Gremlin API is the Apache Tinkerpop standard for graph databases. So I work with a lot of very advanced teams who kind of build social media analytics, fraud analytics workloads. So they are not using SQL API or Cassandra API, or Table API or Mongo API. But on Cosmos DB, they're using the Gremlin API to build the vertexes and the relationships between the vertexes. That's basically called an edge. So basically when we store data, so we store data in a mathematical format called ARS, like atom record sequence. So that ARS kind of is then we build projections on top of ARS. So the projections come in value like 4 type of values. We call it key value pair, the column family pair, or we call the document and the graph. So as I will show the DB hierarchy, how the hierarchy is laid out. So based on your choice of API and the type of data you are storing, the container or the collection is called as such based on the API that you store your data in. So if you're building a graph, your container is called a graph. If you're building a Mongo or a let's say SQL container, we call it basically a container. And an item is called a document or a record within the container. And then, of course, all of these, of course, lie within our data center. So specifically for running mission critical applications, if you're doing, like I work with a whole set of applications which are mission critical. So you need to have SLAs backed for business continuity, 4 nines or 5 nines of uptime and enterprise kind of grade security. All of this is provided by Microsoft Azure. So that's the key takeaway from this slide. Now, on top of the core platform, right, we also expose what we call various data models. This is where it becomes very interesting. So we expose, as I mentioned, in very short, like the key value pair. We provide you column family. We provide you document and graph, data models. And then you have an exposure to the different what we call APIs, which comes to you in the form of Core SQL API, which where the backend it stores data in a JSON format. We'll talk about more JSON in this particular session. We're only covering the Core SQL API. In Mongo, the data is stored in the backend as a BSON format, table as a table. In Gremlin, they basically stored as a Gremlin API, so basically it's stored as a graph. And in Cassandra API, it's a column database, so all of the data is stored in a schema, which is a column schema. So that's the key takeaway. As you choose which particular API to work on, your data gets created in that format and stored in ARS, and then when you fire a query, a projection layer is built on top of it. That's how Cosmos works. Now, basically, uh, without going too deep, so that it doesn't get too boring, before we do some hands-on, just to understand how the resource model works, so that this is like very clear to you. So at a very high level, we basically have four constructs to remember. Simple. So you create in the Azure portal, account. That account basically is basically what we call an Azure Cosmos DB account. So you then create a database within the account. You can have multiple databases. Now, within a database, you create basically a container, or a collection, whatever you call it. And then basically within the container or the collection or the graph, you then have an item. So depending on the type of API that you've chosen, this name of the container and the item will change. Now, the important point is that the tenant, right? The tenant of the Azure Cosmos DB service. So as I mentioned, starts with an account, and that's where you kind of provide permissions to users, and containers and all of that. And database is basically a logical construct here again. It's a logical construct which kind of contains container. And what exactly is a container, right? A container or a collection in very simple term is, let's call a schema agnostic container, or arbitrarily what we call user generated JSON items. We'll explore that in more details. And this container also has a classic ability that, as I mentioned, right, we expose what we call stored procs, triggers, UTFs, all via the basically JavaScript server side programmability. But as a container is very, very important because it's the fundamental unit of scalability. If you ever plan using Cosmos DB or become an expert, or maybe join Microsoft someday working on Cosmos DB, a lot of work, you will be doing on container level. And every resource basically again has a very stable what we call a logical URI, which you will see I will embed in code, which is represented as a JSON document. And except for the item resource, just remember, which is kind of an arbitrary user generated JSON document, right? All other resources have a system defined schema. So that's like an important point to remember. So what exactly is a JSON document? This is very important before we kind of look at code, because we are focusing on the Core SQL API. So, the format, very simply put, in which Azure Cosmos DB data model breaks data down when you store it, or data stored is broken into individual what we call document items or entities. Do not worry if you are not grasping all of this right now, because as you kind of work on this in more advanced cases, right, this will become all very objectively simple. So in JavaScript, right? So if you, for example, see right in this, right, you have device and your type, a mobile, you have captured a send token value, and then you have spool refs, let's say two different values, right? So this particular lightweight data format in which data gets stored, in Azure Cosmos DB data model is referred to as a JSON, and it's a very, very important thing because all of your, data encapsulations, all of the projections are built on top of this JSON document. One important more point to cover is the container level, as we again come back to. This is where the magic starts happening. Why? Because till the account, it's a logical representation, database is a logical representation. Container technically is where the magic is kind of choice of your let's call it API becomes very important, because since Cosmos DB is a multi-model database, right? A container can be projected into several different things. So if let's say you are choosing the Core SQL API, then we will call the container basically a collection. If you're using the Graph API, we'll call the container basically a graph. If you're coming in with the table APIs, right, we'll just call the container a table. This is like very important point to remember. And also this is the place where kind of let's call the logical boundary gets shifted into the physical boundary, because that's where the physical resources come into play. So first things basically what we do is kind of name the container, we give a ID, Then there is a concept of request units, which is very important. So as of now, let's say, very simply put, you can think of it as a logical combination of compute, memory, and I/O, which is required for doing all of those fancy things we do in a database, right? Indexing, running queries, and all of that. And this is also where the green tick is the probably the most important point. Um, if you are planning to work with Cosmos DB, is you choose something called a partition key. Now, this at a top level design decision, right? So this is extremely vital because the way your queries come in and how you kind of distribute your data kind of is validated by this choice of a partition key. And the effective choice is very important because when your queries come in, it could be inserts, upserts, deletes, right? The logical grouping of those queries for all the items happen together. So that's very vital for distribution of your data. So possibly we can't go deep diving into partition key choice today, but there are certain best practices of choosing partition key. So when I get involved with app teams and developer teams basically for building their applications, this is the most important consideration and discussion and debate that we have of choosing a partition key. So the core essence, in very simply put, like I created this slide, is basically what happens is the essence lies in how do you group items together based on their partition key results in being queried efficiently. That's what the entire science of choosing a correct partition key is all about. Why? Because this second point is very vital. All the documents or the items or records, whatever you call it, right, with the same partition key, they are stored together physically, and they basically are grouped into what we call reside in logical partitions. This means I could query across a, like for example here, I'm in this JSON document, right? Like I could query across a department very efficiently, because I've chosen the basically department slash name as the partition key. So it stores all the device telemetry of each department in separate what we call logical partitions. So that is the core essence of a partition key. So choice of an effective partition key is vital for, as I mentioned, efficient queries, ensuring that even if you write queries, whether in the concept of Cosmos DB, we have a concept of point reads, we have a concept of in partition query, what we call out partition query, and then a fan out query. So the fan out query is bad to have because of performance, latency, and cost implications. And in partition query is always good. So when you're firing a query with a basically partition key in the query, you're telling the engine, right, that, hey, please go to look at this particular logical partition. And it makes a quick retrieval of the data and gives to you on the application end. And there is also a concept of physical partitions, which we will not go into today. So these logical partitions reside on top of something which we call physical partitions. Physical partitions, you again don't have to bother about. Microsoft takes care of it. So basically, it's a combination of a thin SSD slice with a compute. So you define the partition key, you have logical partitions, and they sit on top of physical partitions. But this concept of a partition key choice is very vital if you are trying to build complex applications. Now, various SDKs, we support a lot of SDKs. As I mentioned, right, we support .NET, C Sharp, we support Java, Python, we have JavaScript. Definitely, we have Node.js. My bad, it should be separate 4 and 5. Azure CLI, REST, we have also support ARM templates and PowerShell for you to do a lot of automation work. So a lot of SDKs are supported, and if you are working on any of these programming languages, you'll feel at home, working with Cosmos DB. So before we kind of build something or deep dive into an application, right, just to quickly understand like what this is all about. So we have different choice of libraries, right? So again, as you see, the Microsoft.Azure.Cosmos is nothing but just a library which kind of represents the latest .NET SDK, for the Azure Cosmos DB CLI, basically Core SQL API. And here also, if you see carefully the different classes which are exposed by the library, they again are representing the DB hierarchy here. So for example, you have the Cosmos client. So it's basically a client-side logical representation, right? You create the client first. Then you have a database. So this is again, see, a logical representation of a database. Then you have a Cosmos dot container. So container basically represents a logical container on the client side. And then you basically use different functions on the container to create items, add items, update items, or delete items, or do bulk inserts and all of that. We will be using that. So Quickly let's take a look at one of the applications and do some hands-on so that you get a good objective view of what this Cosmos does for you or can do for you. So let me share my screen correctly. Can you see my screen? Oops, no, hang on. Yes, screen 2. Yes, so I have opened up Visual Studio. Now in Visual Studio, basically, you can easily create a console application. And I will run through the different steps needed to really create an application and kind of get started. So easy is like basically you can go and create a simple project, and in this you have loads of kind of projects that come up. So you can always search for a console app.net and just take a simple console app.net for the .NET framework. And once you go to next, you can name this certain application, choose a relatively new .NET framework. So I've already created one, so I will not create from scratch. I've called it kind of Azure Bootcamp Demo version 1. So as I was mentioning, right, as you saw, this is the core place where kind of you start with a namespace, right, definition. And this is where the latest .NET SDK for Azure Cosmos DB, as you see, this is the latest .NET SDK version library. Within this, right, so what we will do is basically we will define a console app from .NET. We will kind of create a structure where we have created an item with 3 different type of documents. We will give a structure to the document also, or you can change it also because it's for dynamic schema, right? And we'll load it into Azure Cosmos DB programmatically. And just to kind of explain this also, I hope my this is also visible. Correct. So this is what the Azure portal looks like. So I have an Azure Bootcamp, 2022 account which I've created, and as you see right now, it does not have anything. So it says refreshing the list and successfully pulled the list. So if you go to Data Explorer, I've chosen a Core SQL API to create one. As you see, no data and no notebook is there. So when I refresh, nothing comes up. So once we have correctly loaded data, it should ideally come up, and then build a more complex application. And then we'll do some examples of, I'll show you some examples how to write like very efficient queries. So if I go back to this particular application, so basically class program always it starts with private static. We kind of define read only an object. And then very important is here, and I'll show you where to pick this up from. So you do a URI. We will pick this up from the portal itself. So this is basically nothing but the connection point, endpoint. Um, so read only here in place of endpoint name, you need to give the primary key. Basically, so we will pick this up also from the portal. Post this, as I mentioned, right, you basically define a connection point. So you do a private Cosmos client, and you can press or write or give a name the Cosmos client. And so this is basically defines the let's call it endpoint Cosmos client for my integration of the application. And I will also have a private, basically a database, which is database. Let's say call it, and I will have a private container. So this is the good way of creating an application. Of course, when you're defining a Cosmos client, it comes with a what we call a constructor, which we will kind of load. Here, this is where you give the name of the DB and container. And this is where, along with the partition key choice, you need to make a choice. So let's say I will store data of family members, different people, right? And I want to query such that I want to see for a given family, what's the first name, whether they have a pet, what school they go into, and all of that. So it's a good query pattern for me. Queries like top 5, top 10 queries, right? That was on the last name. So last name gives me good cardinality. Cardinality means variety of the data, right? Should be the partition key. Name should be the bad. It's worst because let's say my name is Subhashish. There could be 10 million Subhashishes, right? So all of those logical partitions or all of these items will land in one single logical partition, which is bad. So I basically define private string, database ID. Then basically, let's say I will call it bootcamp, DB, and you have to do the same. I got terrible one. Private container. I call it container ID. Should be, let's say, bootcamp container, something like this. We can call it. Now the core part of it, this is, of course, this is the main where you do some basic error handling, right? I mean, to start the basic operations and call a get started demo sync function, and then in case there is a catch, you catch it. Otherwise, if there is no issues, you in the very end, finally you execute that end of the demo and you kind of exit. So we basically want to create three different functions or methods which we will call from specifically what we call the main. So what are those actually? So one is the public async task, get started demo sync. So here what you basically do is you take this and the Cosmos client which you have already defined, and then there are multiple ways to define what we call the constructor. The most efficient way of doing it is passing two parameters for this constructor. So it takes basically two variable values. There is also another way where you kind of define basically the connection mode and all of that. You really don't need to worry about it unless you're building really highly available applications and all of that. So create, let's say I first need to create a database async. Then only first the database has to come. Again, same thing for this. I need to create first a container sync. So this is the same hierarchy. First, always you should have a Cosmos client. You pass parameters to the client. Then you have a database. Then you create a container. And let's say I just have one item which I kind of need to add, and we will kind of exit the program. So what is a good practice? I mean, you can directly create the database, no harm in it. But a good way of looking at it is you should always check whether the database exists or not. That's a good way of checking it. So how do you basically write it? So we have certain functions specifically for that. I mean, you can always do this new database, but not like kind of recommended. So you should do the Cosmos client and then basically do a create database. Now you see there is a function called create database async. It sends a request for creating a database, right? It tells you if not exists, async is the correct way of creating a database. All you need to do is basically you pass the database ID parameter to it. That's the correct way of doing it. And then basically you write a control kind of console write line. Again, it's a best practice. It's nothing that have to do, but it's a good practice to write like this. So \n then you do a this dot database ID. So you print out like what database you have created, right? In case it exists, it will exit and it will not create the database for you, so that you don't kind of run into any issues or any error per se. That's a good practice of writing code. And then you have this database again, right? I'm now creating a what we call a container. So this Cosmos client dot I will create container sorry, my bad. In Cosmos client, always it is database. So for here, I need to give this dot database, and then you create container. If not, correct. Never make this mistake. So on a create database, it is on Cosmos client, and create container is on the database. Correct. container, then you give the partition key choice. Typing has gone for a toss. So very important for this is to note always that last name is the partition key. So this is very important. Why is it showing like this? Await this create container if not exists. Last name. Okay, we'll take a look. Last name is a PK. Then basically console.write line created container. So we can do so instead of this, we will do ping. And await. So you have this cannot implicitly to Microsoft Cosmos. So I think if exists this semi-var, because this is container, this is for the database. Basically now after that we are adding certain items. So for this, the best practice is you can do this structure inside this particular program.cs file, but it's better to create a what we call a CS file, a class file with structure. So structure again, basically we have a property called ID, which is the unique identifier. Again, this is very very important in Cosmos DB when you see the data coming in. So we use the JSON property name as the key ID, and then public string, we need an ID to identify. So this ID is what? It's like, let's call it very simply put, it's the unique identifier of that document within the container. And I'm storing last name, first name, and location. Let's say I want to store where this person is staying. So how have I created the item structure? So when I'm doing add item to container sync, this item lacks a bit of no worries at all. So new family. So let's say I have a Ghosh 1.1 family. So this particular item which will be created will be identified in my query pattern using this ID. So when I say ID on Ghosh.1 I want to use, so this particular document will be Ghosh.1. So let's say I live in Bangalore, I put in items, and what say, let's say I have two same families. Is it possible to store data? As you see, absolutely yes. All I do is basically I change the ID name, ID value actually. So the first name, last name. So I have a friend Rajinder who is based in Gurgaon. I have a friend called Ravinder who is based in Seattle. Correct. So I store it accordingly, and then when the data comes in and gets stored, this ID value, all operations will be routed to sing family 2, and sing.1 basically will be for the item which is stored, and specifically identified by the sing.1. So the important point to remember here is the items need to have a unique identifier for the item operation, and later I will show you what a point read looks like. There this ID plays the most important role, along with a read item async function within the .NET SDK, which gives you something called a point read, which is a very efficient read. But before we do all of that, first let's create an item, right? So how do you create an item? Create an item representing Ghosh family. So let's say I want to put this. So you need to do item response family, and let's call it Ghosh family response. No problem. So await this dot container. After that, you need to do create item async. This is the correct way of doing it. There are many ways of doing it, but this is the ideal way of writing actually. Family you do, and then I have for Ghosh family basically a new partition key you have to define. Sorry, it has to be capital partition key. So this partition key for Ghosh family is already, oh my god, sorry, Ghosh family dot. For this, I know it's the last name, right? So last name is the partition key for me. And then, of course, in console, I do a write line basically that successfully created one item in DB with ID, let's say 0 operation consume. I do one basically RU. So RU stand for request units. Slash sorry and this kind of using wash family response ping goes to resource ID not ID. So I basically will read that and then kind of also give a family response dot. So this is a very important property right now which I typed in. This in every function or in operation you should use. This is a request charge property. It gives you an average, not an average, perfect value, and gives you an average indication of how many request units, that is the cost factor of your operation is. And then there is an entire science behind it, how you can optimize the request charge for that given application, for that operation. So ideally speaking, we will not write code, but we will do the thing which I love the most, copy paste. And in copy paste, we will do representing sorry, my bad, sing one family. So this one we will need to change to sing one family response. And this is perfect. Above we have called it sing family, so this has to come here, sing family new, sing family dot last name. Perfect. I've created one item DB with operation ting. This should come sing one family response. Right, and then again we come to sing two family. So this becomes sing two family response. And this is exactly, we have to copy paste from here. Always it's good to check in case you are making anything wrong. No, you are not. Then basically you created one item. Here you have to change sing to family response. That's charge property. So once you have done this, basically all you need to kind of do is save, build. Yeah, it's a simple process. And before we kind of fire, because if you fire now, nothing will happen because we have not given the endpoint URI in the primary key. So this should ideally speaking come from your portal. So I'll quickly show you. Like I'm exposing it, I hope you will not expose in your application, but this is a simple application, and post this call we will delete it, so no worries. So all you need to do is copy paste that particular link here, and again I will go back to it. So you have keys, which is very important. You comes with two pairs, it's primary key, secondary key, and then you have a primary connection string and a secondary connection string. So you have to ensure this primary key, and then also you have, if you only want to give access to people to do read write, you should copy this. And if you're building an application, let's say for a given use case where only you want to give people access to read only, you should then only use the read only query, otherwise the write will fail. So I take the primary and then kind of will copy paste here. So build, and then assuming these are all correctly chosen, yep. So it basically then fires up for you So it begins operations, and then it shows you a parameter also, the connectivity and all other, how much process memory you're taking. So it creates a database, it creates a container, and it has created one item with the 1 dB. And operation, this is what I was talking about. This is very, very important. This is, as you can see, note down the values. It's 6.67 RUs, right? Ideally speaking, if you are creating one read of a 1 KB document, is defined given certain parameters. Of course, if you're using direct connectivity, using read item async via the SDK, is defined as 1 RU. Because as you see, you're creating is for around 6.67. So there are ways to kind of optimize this value. So let's go and take a look, like what exactly have got created. That's the crux of the matter. So if I go back to Azure Bootcamp and refresh, so as you see, this has got created. That's the best way to look at it, is at the data explorer level. So it has created basically a bootcamp DB along with a bootcamp container. Now there are certain parameters here which maybe are beyond the scope of our discussion, but I'll just kind of mention it. So throughput is basically, you can define it as auto scale, where you have a very intermittent kind of a workload which scales up, spikes down. It's very difficult to predict, right? And give a provisioned, like a RU, a throughput for how many type of operations you want the container to handle. Then you should choose auto scale, or you can choose manual and scale it up on your own, right? The minimum to start with is 400. You can't go below this, because a garbage collection and all of that requires some, uh, you know, let's call it RUs for that. 400 is the minimum. It gives an average cost of monthly daily. Settings is basically time to live, right? You can kind of expire items. That's one of the very core functionality in Cosmos DB, by the way. I work with a lot of teams who kind of their workload is such that they don't fire, they kind of upload data, upsert, and then don't delete. They basically expire the items. So you can define a basically time to live and give a certain value to it, post which the item will get kind of deleted on its own. As you see, this is locked. Can I edit this? No. So this is very, very important. So this particular, let's call it again, going back, the partition key choice is very, very vital when you're creating it. So when you are defining this create container, if not exists async, this is the most important, design level decision. Possibly in the future, we are working towards, let's call, enabling, if I choose my words very carefully, enabling a feature on the portal or via the SDK, which will enable you to change the partition key once defined. But as of now, you cannot. So your choice of a partition key has to be absolutely spot on, has to be dead on. Indexing policy, again, it's a science of its own. We will not go into this today, possibly, because it will open up a lot of things. So as you see how the data got kind of created, right? So we have 3 items which we kind of uploaded. ID is the ID that we gave, right? So that's the unique identifier of this particular document within the container. So I may have a million documents, right? I need to then ensure that this ID is not a string value. It's a bad way of doing it. Then it should usually be a hex value, or a composite of hex with string, or pure numeric or UUID, or random identifier, right, which has a huge scale to it, which should be high cardinality in nature, right? Then last name we mentioned, first name property we gave, location we property we mentioned. These are certain properties which we did not define, I did not define, right? But it got added. So these are referred to as the system properties. So RID is the resource, identifier for that identity, let's say for this particular item. Then E tag, very, very important, is basically something which we use. If you are aware of what we call in databases MVCC or OCC, it stands for multi-version optimistic concurrency, or Azure Cosmos DB kind of supports optimistic concurrency model, which kind of ensures that there is data integrity. So if you have multiple users kind of reading data, that's okay. Writing data, how does OCC kicks in? OCC ensures that. So the ETAG value is very important if you have multiple users from different regions. Updating, upserting, where you read and then you insert something, right? How do you ensure that every corresponding item gets, all of the changes get tracked? So we ensure that the writers don't block the readers. Correct. There are certain databases, the classical databases, they work on pessimistic model. It's a database concept like pessimism. What happens is you have multiple functions coming in or multiple workflows coming in, right? So the writers block the readers. Correct. In Cosmos, we don't do that. So ours is basically OCC, optimistic concurrency. So the way you handle MV OCC is basically using e tags. So what you do is you define an e tag value and then you match it. And if the e tag on your query operation is most recent than the one which is stored, the code goes through. Otherwise, it gives you a 412, what we call an error, which is called a precondition failure. Then you know that you need to check for the latest e tag value and then retry that operation. This is like, so it is very important. So this is how basically data kind of gets created. And then of course we give you multiple other facets, like you can write a SQL query. So select star from C stands for the container. It, as you see, it basically gives me an output of all the three documents that I have, and also gives you the cost. So the request charge was 2.3 RUs for given document. So this is how we kind of do the entire validations specifically. And then of course there are a lot of other parameters to it, but this is what something I wanted to discuss. And possibly one more quickly we will see, that is some things very relevant to it because we have a few minutes, um, which maybe if you're interested in or kind of wanting to work on Azure Cosmos DB, it will make sense for you. So hopefully you don't take my IDs. So another important thing is basically in Cosmos we have 6 type of query patterns. Like very very important to remember or note if you are planning to work on Cosmos. So if you're doing a full table scan, it's pretty expensive. So you should prevent doing select star from C in databases. And again, there are a particular way of doing something which we call a point read, which is excellent way of looking up items, but then assuming that for one given item or a document, like for example there I had the ghost.1, right? That was the ID for me. So I can kind of replace this code with await container or read item or sync instead of food, basically the class which I use family, and then here ghost.1, and the partition key was the last name. This is the best we are writing code. Why? Because the RU consumption will be the lowest, and it will also give you very low latency response. If you see the same query basically is this particular query. So this is again an in partition query, we call it. So you do a select star from C where I do a C dot food group. So C food group is basically nothing but my partition key, and I give the ID. So this could be like family, and this could be Subhasish. But this is an example of again an in partition query. So what is an example of an in partition query? It is a query which has the partition key. But again, there is a fine-tuned difference. This code will cost more than this code. Why? Because here you are bypassing the query operator. Here you are not. So there are again a lot of science to it, how you can basically work, on how to kind of optimize the query. We'll not go into all of these details today. We have kind of come to a closure. So I will rather open up my deck and kind of finish the points I had. So this is more or less like what I planned covering, which gives you an overview of what Cosmos DB is all about, and possibly how you should start working with it if you're planning to kind of, and then basically take next steps of building applications, and understanding the architectures in which they are kind of leveraged. That's what it is all about. So and definitely do check, test this link out. It has a lot of use cases and architectures. So that kind of finishes my session. Yeah, thanks.
As we come to the end of the insightful event, on the behalf of UPES CSA, I would like to thank Mr. Subhashish Ghosh for such an informative session and for sharing great insights. We are really glad that you could set aside some time from your busy schedule and be present here with us. It was our pleasure to have you amongst us today. Look forward to having see you again. Thank you everyone for attending our session. I hope you learned today.
Yeah, thanks. Thank you so much, Vrinda. Thanks, team, as well. And it was pleasure, meeting all of you. So look forward working with you. Thanks, then.
Thank you, sir.